Hello all, welcome to the lecture on normal form of the matrix. Suppose what is normal form? Suppose A is any matrix, then any matrix is converted into any of the following four forms. That is called a normal forms. Now, how this convergence is going on? You look at the row transformations and column transformations simultaneously. Apply row and column transformations on a matrix, and you will get any of these four form inside your matrix. Then we can call that form is normal form of our matrix. Now question is, what is this I? And I is usual identity matrix. Suffix R gives the order of that identity matrix. And the another significance of this suffix R is it is a rank of that matrix. So simple thing is, we are investigating the size of identity matrix hidden inside our matrix. So in simple language, we are looking at the number of linearly independent rows or linearly independent columns which are there in the matrix, right? And this investigation is goes along with simultaneous rows and column transformations, right? So with this brief introduction to the normal form of the matrix, we will start with a simple example. So question is, find the normal form of the matrix and hence find its rank. And matrix is 2 minus 3 4 4 4 1 1 1 1 2 3 minus 2 3 3 6. So if you look at this matrix, it is again 3 by 5 matrix. There are 3 rows and 5 columns. So one thing is with you, that its rank should not exceed 3. So it is clear that maximum size of identity matrix which is hidden inside this matrix is 3. Okay, so now we will proceed toward the example, toward the solution of example. So this is my identity matrix, right? Now see, our idea is we will travel in this direction. We will make first entry 1st entry 1, and everything below this entry 0. Then everything on other side we will make it 0. Then we go for diagonal, we make it 1. Then same pattern, everything below this 0, everything on this side 0. Then we go to third diagonal entry, everything below 0, here 0, and this is how we will solve the matrix for its normal form. So this is idea, and we will do this by using rows and column transformations. Now this is a matrix of size 3 by 5. So first thing is, I need first entry to be 1. First entry to be 1. So I am going to replace first row with second row, or you can write it like this: R1 replace with R2. After this, my matrix is, so R2 will be first row now, 1 1 1 1 2, then 2 minus 3 4 4 4, then 3 minus 2 3 3 6, right? Fine. So now there is a 1 1 in 1st position. So we will make this 0 and this 0. So for this we apply row transformations. So apply R2 minus 2R1 and R3 minus 3R1. So after this row operations, our matrix is, so there is no any change in the first row, so that will be 1 1 1 1 2. Then multiply this by 2, subtract it from here, so 2 minus 2 0. Multiply this by 2, subtract it from here, so it will be minus so it will be minus 5. Multiply this by 2, subtract it from here. 2 multiply by 2, subtract it from here. 2 0. Then multiply by 3, subtract it from here. 0. Multiply by 3, subtract it from here. Minus 5. Then multiply by 3, subtract from here. 0 0 0. Right? Now these are 0. So look at first row and try to make everything 0 using column operations. So since first column has second and third entry 0, so only first entry will be changed after the column operations. So C2 minus C1, then C3 minus C1, C4 minus C1, and C5 minus 2C1. So after all these column operations, only first row will vanish. So 1, then this 0 0 0 0 0 0, and there is no any change in second and third row because second entry and third entry of first column is 0. So it is minus 5, then 2 2 0 0 0 0. Right? Now we have to make this one. Now to make this one, we will apply minus 1 by 5 into C2, second column. So my A is 1 0 0 0 0, then this 0, then this will be 1 2 2 0 0 0 0. Now after this one, I will make this 0. So to make this 0, I am going to apply R3 minus R2. So after R3 minus R2, my matrix is, there is no change in second row, but there is change in third row. 0 minus 2 minus 2 0. Now after this one, we will reduce second row to 0 by using column operations. So apply C3 minus 2C2, C4 minus 2C2. Right? So that converts A into 1 0 0 0 0 0 0 1 0. Now C3 minus 2C2, so only this entry will be 0, this entry will be 0, and everything else remains as it is. Right? So after this reduction, we have to reduce this 2. So apply minus half to R3. So minus half to R3 after this operation, right? After this operation, there will be 1 1 in third row and everything else is 0. So after these operations, my matrix is 1, then 0 0, then 1 0, then there are this 3 0 and 1 1 0. Now see, this is extra one which is beside the identity. So apply C4 minus C3. After this operation, only this one converted into 0 and our A is equal to 1. So if you look at this carefully, this part of our matrix is identity matrix, and what is size of that identity matrix? Its size is 3. So I can write normal form of A is equivalent to, so normal form of A. Now I am going to put the identity. What is size of identity? It's of size 3. So identity, and then see I have this 3 by 2 0 matrix, this 3 by 3 identity matrix. So this 3 by 2 0 matrix is represented by single 0. This is a normal form of our matrix, and remember, significance of the size of identity matrix in normal form is rank of matrix. So therefore rank of A equal to 3. So this is how a normal form of a matrix is evaluated by simultaneous rows and column transformations, right? So there are few examples for homework. You please go through it to understand the concept. Thank you. In next lecture we will go for the system of linear equations. Thank you.